So a hydrogen molecule, H2, would use these 1s orbitals to overlap to form a molecule. So we can imagine that we have a 1s orbital on one hydrogen and a 1s orbital on another hydrogen. And when those combine, both additive and subtractive, we get a bonding orbital that's lower in energy and an anti-bonding orbital that's higher in energy. We can represent the way that this bonding happens using an energy level diagram like the one shown here. And so on the left side of our energy level diagram, we have one of the hydrogen atoms, and so this is the 1s orbital, and the other hydrogen atom, here's the other 1s orbital. And we see that when they make a bonding combination, that goes down. And so now this is the H2 molecule. Here's the sigma orbital. And the sigma star orbital is the one that's higher in energy. And so the change in energy here is the change in energy related to sigma between the energy of the molecular orbital and the atomic orbitals that were used to make it. And then we have the change in energy of the sigma star orbital, the energy difference between the atomic orbitals and the sigma star molecular orbital. We can also populate this molecular orbital with electrons. So we know that the 1s orbital on hydrogen A started out with 1 electron, and the 1s orbital on hydrogen B started out with 1 electron. And so we can imagine that when a molecule is formed, those atoms put all of their electrons in a pool, into the molecular orbital pool. And so then we fill the molecular orbitals with the same number of electrons according to the Aufbau principle. So in this case, we'll fill the lowest energy orbital first, and since we have 2 electrons, those electrons will be paired. So instead of having single individual electrons, we now have 2 electrons in a bonding orbital, which is another way of expressing that there's a bond between those 2 H atoms.